at the same time. So you may hear another notification that this webinar community call, Zoom says webinar, so I have to use it because that's the words that came up, is now being live streamed. I am muting myself in the background. So awesome. We are live on Zoom. We're live on YouTube. We're going to get started here in just a couple of minutes. There's an immense amount for us to cover today. But as always, while I tweet and drop in Slack and Telegram, and if you're not part of those channels, please come join us, that we are live. Alexei, would you mind welcoming the people that you recognize?
Sure. Welcome. I see so many people joining. Interesting who was the first. Maybe Alex A or maybe Alan Tal. By the way, welcome, Alan. Nice to see you again. I'm happy to see regular visitors of our webinar. Hi, Ankit. Christoph, nice to see you. Nice to see you online. Denis, Eric, Evgeny Kruglov, Konstantin Ilchanka, Kin Lon Lo, if I pronounce correctly, I hope. If not, I will try to correct. Nick Rod, Srilesh Kanoli, San Bat, Todd Yokum. So many new names that I don't recognize. And I'm happy to see so many new people on my webinar. Vitaly, Yudzi, welcome. We will start in about 1 minute. And if you did not tell your friends about the webinar, it is the time to send the link to our YouTube channel because we are streaming live on YouTube.
Amazing. Thank you, Alexei. And for some reason, my video has decided to freeze. I apologize. But yeah, thank all of you who are here and continuing to see more and more humans roll in. Whether you're watching this live now or whether you're catching the recording later, if you happen to be on the call live, there's a lot of value in it because we do provide time typically for live Q&A at the end. If for some reason we're not able to get there this time around, we will indeed make sure that there is that questions that come on YouTube, that questions that come in Slack, that questions that come in our Telegram channels, in our GitHub, that they are addressed as well. So as you have questions throughout, please feel free to drop them in. We'll make sure that we're answering them. This is an immense release, and it's an exciting release because it's the autumn release, which means I can finally put on my bright yellow vest and not be entirely too hot in the office. It is like 50-mile-an-hour winds outside here in Amsterdam today. So it's nice to be wearing something kind of warm. But we have a lot to cover. I just got a sneak peek of the slides, and they're super exciting. So as folk continue to join, as we continue to promote, I think we should just go ahead and get started. Alexei, would you mind taking it away?
Yeah, sure. You are so excited about my slides, maybe even more than I do. Let me check.
It's almost like it's my job to be excited about the things that we build.
Okay, so let me start. This is ClickHouse release 23.10. 23.10, our autumn release. I will try to spend not all the time for new features, and we will supposedly have just a few minutes for your questions. So what it is? We have 23 new features, 26 performance optimizations, and 60 bug fixes. This release has more performance optimizations than probably ever released before. So let's start. Let's take a look. What do we have? Let's start with something nice. Not sure about something exciting, but let me check. I will tell you about some new stuff, and you will tell me how much do you like it. Okay, a new query, show merges. We have many show queries. Some of them we took from MySQL. Some of them we just invented because we like to invent the new stuff. So we have show process list, show databases, show tables, show engines, show functions, and now also show merges. What it does, actually it is about the same that you get if you type select star from system merges. It is slightly different, it is slightly more user-friendly. Like if you run select star from system merges, you get all the details, all the numbers in a precise format. If you run show merges, you will get something nice like pre-formatted sizes or estimation of completeness. For example, currently there is a merge, background merge for table default checks, and it will finish in 10 milliseconds. So it's probably already finished. What else? Show setting. From my standpoint, this feature is totally unneeded. I don't know why do we need this feature, because we already can get the value of a setting with this query. Select value from system settings where name equals to whatever you want, like max block size. If you don't want to type this long query, do this. Select get setting of max block size. So get setting is just a function, and you can easily get the value. But for some reason, in ClickHouse 23.10, we also have this query, show setting max block size. And this feature is so interesting that we have a full-length video for this, about this feature, like 1 hour, explaining what it does. And I strongly advise you to check this video because you will find out why exactly this feature was added to ClickHouse. And by the way, Dale, do you know why do we have this feature?
I'm guessing MySQL compatibility.
No, MySQL does not have it. No database other than ClickHouse has this query. Okay, let's ask people in the chat, in Zoom, or on YouTube, if you can guess why did we decide to add this feature. Any hypothesis? Please share, and maybe you will be a winner. Okay, I will count 1, 2, 3. Okay, any hypothesis? Okay, it will be your homework. Another uninteresting feature, a new function BiteSwap. It is pretty easy. You pass one number and it returns another number with the order of bytes swapped reversed. For example, sometimes you have to convert a numeric representation of IP address from native byte order to network byte order and vice versa. And this nice function will do what you want. Thanks, Priyansh Agrawal, for developing this feature. And this feature is not so easy to explain. It is named largest triangle tree buckets, or simply LTTB. It is for downsampling time series data, but not for just averaging in different intervals, but some sort of smart downsampling. And there is even a paper about this function, so it should be pretty smart. And to explain it, I have to show it to you. Let me copy-paste some queries and show how it will work. Okay, I have a server running ClickHouse. I will connect to ClickHouse with ClickHouse client. It is version 23.10, so it is already updated. And I will fetch some time series from the system asynchronous metric log table, like this. I will get the time value from the past 1 day for a certain metric, total parts of merge tree tables. Okay, I have it. Now I will try to apply the new function LTTB, and it looks like this. It is an aggregate function taking the first argument is time, the second is value. And it has also a parameter how many buckets of time you want it to prepare. So it will downsample the time series into 1000 of buckets of time. Okay, let's run it. It works. And it returns a single value because it is an aggregate function as array of tuples of the time and aggregated value. So if we want to make a graph out of this data, we have to unfold this array, and we can use array join function. Let me show it to you. Okay, we will just take this result and make array join. Okay, here it is. Nothing interesting so far, but okay, it works. But how to explain what it does? Let me visualize this data. So I will use our advanced dashboard for this. So this is the dashboard. Let me maximize these charts. And this is the original chart with 86,000 of time points. It is very precise. It contains everything, but it does not look really beautiful. It looks a little bit messy. So we can downsample this chart. And it is easy. We can just calculate the average of value for every time interval. And it looks like this. Not bad. But now let's compare what LTTB will do with 1000 of points. So about 1 minute for every point. And it looks like this. What is the difference? And why do we need this approximation, not approximation, the opposite, aggregation method? And the answer is, you see, it actually gives the variance in the data. So on this graph, you can see that there is a lot of variance in every minute. On this graph, this information is lost. But if you use this smart downsampling, you get this information and you still downsample the data. Yeah, it is pretty nice, and I hope you will find it useful. Okay, What else? Array random sample. It does not even require explanation. A function, it takes an array. It takes the number of points, elements from the array you want to return, and it returns a random sample. Every time you run this function, the sample will be different. Pretty easy. And this function is not so easy. It is named JSON merge patch. Let me explain it live with a demo. So let me just copy paste it. So I have one JSON, DBMS ClickHouse, and another JSON, is it good? True. And let me merge these JSONs together. It should be, the result should be unsurprising. I don't want any surprises. I want everything to work just as expected. So let me check if it will work as expected or not. Yeah. DBMS ClickHouse, is it good? True. No problems. Now let's try this. I will use this JSON and merge it with another JSON, DBMS MongoDB. What it will do? Maybe it will create an array of all the values here. Maybe it will throw error. Maybe it will just replace the value. Maybe it will do something unusual. Let me ask an expert. Dale, do you know JSON?
As well as anyone else. What do I expect it to do? I would expect it to keep the former keys. So it will keep ClickHouse and MongoDB in that instance, I suspect.
Okay. Let me check. So it just replaced the conflicting keys with the new value. So now it outputs DBMS MongoDB, is it good? True. So no surprises here. Nothing special. It just works as it should. And apparently this function is from some of SQL standards, probably from SQL JSON. Okay, what else do we have? We have a function named format query. And sometimes you need it to format your query, especially if your query looks like this. It looks like a trash. And usually if your query is generated and this query is clearly generated, it has some cryptic aliases, cryptic names. I don't understand what it does. Okay, so let me just take this query and copy paste it here. And actually, I don't need any function because when I copy paste query to ClickHouse client, it is automatically and always formatted. But sometimes you don't use ClickHouse client, you use HTTP interface, or you want to process this data programmatically. And for this purpose, let me try to use this function. Select format query. And here I will use Postgres style literals like this. Let's take a look. Yeah, it works. And the query is formatted. Also, I have format query single line. like this. It is also formatted not so beautiful, but at least it normalizes the white spaces, everything else, like keywords, case, and everything that you need. Just in case you don't have to use this function, you can also use ClickHouse format. Oops. Yeah, for ClickHouse format in shell, you have to take care because these substitutions will be interpreted. So at least you know at least one advantage of using format query instead of ClickHouse format. And by the way, if I write select format query, I want to write the same query inside. So it will be select format query from select format query. Can I do this recursively multiple times? Interesting. I will try because I like doing experiments, random experiments. Okay, it works. Somehow it works. I don't want to oversmart myself with these experiments. Okay, this feature is maybe more interesting because it will be more complex to explain. Argmin and argmax as combinators for aggregate functions. And these combinators allow you to apply aggregate function to the set of values when another value is the maximum. Let me show it to you. So first, let's prepare a data set with 3 records. I will use select from values. Values is a table function, and I just list these records explicitly. So we have C1 with 2 values and C2. And you probably already know that ClickHouse already has argmax as an aggregate function. So we can extract max from the first column, and it will be 2, because we have only 2 values, 1 and 2. Argmax allows you to extract another value when a particular column is the maximum. And let me try this query. So we will extract this column when C1 is the maximum. Okay, and it returned what we expect, the value world. But the problem, there are actually 2 records with the value C1 equals to the maximum. So what of these, what particular records we want to get? And what do we want to do if there are many? And for this purpose, you can apply aggregate function for all these records. Let me show it to you. For example, I will do like this. So we are applying group array aggregate function for all the values of C2 where C1 is the maximum. And there are 2 these values, and we get all of them. Yeah, it is pretty nice. Probably you don't need this feature. But if you need it, you will be happy that finally we have it. And take this as an example. Amos Bird, external developer, needed this feature, so they just went and contribute this feature to ClickHouse, and now this feature is available for everyone. Okay, now something pretty boring. Parameterized queries, parameterized alter queries. So in the usual alter query, you can make substitutions with query parameters, and you can use these substitutions for a partition identifier and for a table name. You don't have to, but if you want, yeah, now it is possible. Okay, what can be even more boring? Untuple. Better support for untuple with returned names. So if you have a tuple, you can apply a special function untuple to this tuple, and this special function will return you every element. So the first element and the second. But the problem is these auto-generated names are not so convenient. Now it is fixed. If you specify an alias for untuple, the names will be just as you want. Okay, two more boring features, and then we will have something more interesting. One feature is to make ClickHouse more strict. To tell ClickHouse that it should reject a query if a certain projection was not used. So imagine you have a table. You created a projection on this table to speed up queries. And sometimes you will be surprised if this projection was not used by some mistake, and you want to force it. Just enable this setting, force optimize projection name. And if projection was used at least once, for at least one select in your query, maybe a single subquery out of many, the query will succeed. If the projections with this name was not used in the query, it will just throw an exception. Another feature is to make ClickHouse less strict. It allows to create a table without primary key and without any specification of primary key. A new setting named create table empty primary key by default. And with the combination of default table engine, you can write your queries like this. Just create table without engine, without order by, without anything. It will be created with merge tree engine and with empty primary key. You might think, why do you need it? But some people do. Some people just want to quickly pipe CSV into ClickHouse, create a table, don't worry about anything, and start analyzing this data straight ahead. Okay, so it should be nice. Now let's take a look at performance optimizations. We have so many performance optimizations. This release is probably all about performance. And the first is optimizations for a scenario with many concurrent queries with high QPS. What if you are processing thousands of queries per second with ClickHouse? Why thousands? 10 of thousands queries per second. It is actually possible, it is normal, and ClickHouse should do it, and ClickHouse should do it without breaking sweat. So this optimization is related to removing some lock contention inside a global context variable somewhere deeply inside ClickHouse internals. Don't worry, I will not show you the code. I will only show you the results. And the results are pretty impressive. In the previous version, a certain workload from a production service yield only 200 QPS. In the new version, almost 1000 QPS. And the 99.99 percentile of latency dropped from 75 seconds to just 4 seconds. It is almost 20 times better. If you want to read more, there is a dedicated blog post specifically for this optimization. Okay, another optimization is not for short queries, but the opposite. Optimization for heavy queries. For heavy queries where aggregation has to spill data on disk and has to continue spilling data on disk and continue and generate thousands of files, and then we have to merge these thousands of files. And in the previous version, it was not as fast as it could be, almost 40 seconds. In the new version, 23.10, it is just 4.6 seconds. Again, a huge improvement. Optimization for merges. What it is? If your table is narrow, or at least most of the columns are in the table order by key, then the merge operation could take a lot of time for sorting, for comparisons, and these comparisons are optimized with slightly different algorithm. So usually merging sorted data is done with a heap data structure. And now we are using heap data structure with batching. And it is about 1.5 times faster. Another optimization. Optimization for map subscript operator. You might think it is kind of smart because it speculates on the prediction that the subsequent records in your table in a block will have a similar keys, a similar structure in your map data type. But it works. And actually, it is not complex. It is pretty simple, and it gives like 25% improvement. You should be excited about this optimization because, you know, yes, this is faster. Dale, do you like this optimization?
This is probably, yeah, it does, especially as we don't have JSON production ready, Alexei. So this is a nice optimization.
Okay, I hear. Oh, maybe, probably, I like this optimization. Could you please say it with different impression?
I love this optimization.
Every millisecond matters. I actually just tweeted that. I was like 23.9, elapsed 0.46 out, 23.10, 0.317. Each millisecond matters, and we're committed to making those milliseconds decrease over time. Thank you for your support, and thank you for the contributor, LGBO USTC. Sorry, I don't have names. I only have your GitHub login, but this optimization is really amazing. Okay, another optimization is about the pipeline for short queries and specifically about the selection on the number of streams
for parallel processing. It could be difficult to explain, but instead I will just show you a picture. This optimization makes about 10% improvement on average for queries in ClickBench. And you can see that one query took 190 milliseconds, but now only 90 milliseconds. Another query took 60 milliseconds, now 40 milliseconds. And yet another query took 30 milliseconds, but now only 20. And you might say, what are you doing at work? Why you're doing this optimization? ClickHouse is already fast. What else do we need? But I'm never satisfied with the performance when I see that it could be just a little bit faster. And I always want to make ClickHouse just a little bit faster. Again, this optimization is not from me. It is from Jiabin Sun. I hope I pronounced it correctly. Okay, this is another optimization, yet another optimization about processing of data in ORC format. And ORC format is quite similar to Parquet, and I don't know why there are two different data formats. But all of these data formats are in Apache Foundation, and in Apache there are many more formats. Not only ORC and Parquet, also RC or Trevny, and these formats continue to appear every day. And we have to support all of these formats because people continue developing them. Okay, let's take a look what this optimization worth. So let me show you a demo. So I prepared a file, hits.orc. This file is about 3.8 gigabytes of data, and I will process it with ClickHouse local. And I want to compare the performance between the new version and the previous version. So let me first try to run the previous version of ClickHouse local. Here it is. And let me do a query. Let me run a query from this data. It is fast. It is instant in the previous version. 96 milliseconds for this 4 gigabytes of data. Not bad. Interesting what the improvement will be. There should be an improvement. Okay, 38 milliseconds, 21, 19 milliseconds, 15 milliseconds, 11 milliseconds. It is fast. Let me double check. The previous version, over 100 milliseconds, but the new version, just 15 milliseconds. It is just amazing. But what it actually does, it takes into account the statistics that ORC format has in every block about the minimum, maximum values of every column. And it can apply this statistic, and if the block definitely does not contain the required data filtered by this condition, it will just skip this block. So it is pretty easy. Okay, and by the way, window functions became faster. You just have to enable this setting. Query plan preserves num streams after window functions. And what it does, it actually does not speed up window functions. Surprisingly, it's speeding up the processing of everything that will happen after window functions. So if you have a complex calculation on top of this, like hashing, something else, your query will be faster, like 1.5 times. Okay, do we have more performance optimizations? Yes, we do. Faster skip indexes. In the previous version, we did not reuse the data structure in memory while reading skip indexes for different granulars. Now we reuse them, and the queries became faster. 83 milliseconds, 58 milliseconds, about 1.5 times faster. Okay, now not only about performance optimizations, now about something else. What else do we have? A new data format, NumPy. Do you use Python? Dale, do you use Python at work?
I try not to. Try to just use ClickHouse local, but sometimes it's on a. Sometimes I have to, and I appreciate this feature because I've had to convert data.numpy to files compatible with ClickHouse myself before. So this will save me because I'll be able to write less Python.
Yeah, the same for me. I usually don't write scripts, but when I do it in C++. Or in ClickHouse, I can use ClickHouse for everything, but sometimes I have to resort to Python. But now I have less excuses to do it because now ClickHouse has support for NumPy format, and it can read these files directly. Let me show you something. Again, I will go to my server, and I have a file named images.py. Interesting what it is. It is about 54 megabytes. And let me process it with ClickHouse local. Again, I will copy paste some queries. First of all, let's take a look what is inside. The first 10 records. Just numbers. Array of numbers. What if I will check the data structure with describe? I can simply write like this. Array of uint 8. Okay. Interesting how many records do I have? 70,000. Maybe someone can already guess what is the data. If you can guess, please write in the chat. And if your answer will be correct, we will send you a gift. Like this gift. And now let me continue. Let me copy paste another query. And hopefully this query will do something interesting for you. Maybe it is cryptic, but we're actually just reading from this NumPy data. Oh, what it is? Do you recognize? Dale, do you know data science, machine learning, AI, all sort of fluff?
Not to the level of expertise that I think I'm going to need to know what that is. Is
This
this
data,
um, is this optical character recognition? If you take these images of optical characters, optical character recognition, have you vectorized images of numbers? I can't. It's difficult to see from your image.
and now, is it better?
I can tell it's a sequence of numbers in image format.
Uh-huh. Do you recognize the name of this data set?
No, but we've got some guesses.
Okay.
Yeah, so the Numai Data is an image file, and Rod Prada is suggesting how this is pronounced, minced, MNIST. And it's
Absolutely. Yeah,
training data for a neural network for OCR. So yeah, I thought it was optical character recognition. Is it minced? Is that correct?
Absolutely. Yeah, this is correct. I also want to write UDF into ClickHouse to actually recognize these numbers. It should be really easy. ClickHouse has support for UDFs. You can even go to some API and recognize them. But it is really nice. So Numai Data, and you get it visualized. Okay. Now some interesting function. Let me try to explain. This function is named ArrayFold. And it looks like this. It is a higher order function that takes a lambda function, one or many arrays, something named initial value, and the lambda function takes at least two arguments. One argument is named accumulator, and the subsequent arguments are values from the corresponding arrays. And the function returns a new accumulator. So it is basically to fold an array. And you can do whatever you want. But the question is, why do we need this function? We already have multiple functions to aggregate an array, like array sum, array product, even array dot product, min, max, all, any, string concatenation. And you can even apply any of the existing aggregate functions, whatever, to an array with using array reduce. Like here, you can calculate standard deviation and here correlation between two arrays. Why do we need a new function, ArrayFold? Let me ask. Sorry, Dale, I will ask you again.
I've got a good guess. So you've actually got an accumulator here, which I don't think we have on the other versions of the functions. So that's going to unlock quite some opportunities.
Okay, it will unlock quite some of opportunities. The answer accepted. The answer is acceptable. Yeah, you can do whatever weird stuff. You can take elements and make temporary values containing your aggregation and calculate something like this. I hope you recognize it. I will not tell what it is because it is just too obvious. And it is easy with ArrayFold. You collect data into a tuple and then make a sum of one element of a tuple and put another element to another part of the tuple. Okay, what do we have as a bonus? First, about integrations. about MySQL compatibility. We have to work on the support for MySQL protocol and MySQL dialect in ClickHouse for two simple reasons. We want Tableau Online integrate with ClickHouse, and we want QuickSight integrate with ClickHouse. And now they started to work. Because we have added today's function, we have added support for string arguments instead of date and time to several functions, and a slightly extended information schema. There are also changes in Java driver. It is also optimized. It is faster. I don't have numbers, but believe me, Java driver became faster. You might say, Java faster? What you are talking about? But actually, we optimized it. Okay, Tableau Online works, and there are several more updates for our language drivers. Let's take a look at something else. So my colleagues who like to write JavaScript and not only JavaScript shared me this video. I did not watch this video before, so let me watch it with you and try to comment. So on this video, you write some text, and what happens? It generates a query for you. And you might ask, what is special about this? Because I already have seen this feature like query generation maybe 10 times, maybe 20 times in different systems. And now we have it in ClickHouse Cloud, in a SQL console. And what is special? Why did not we add it half a year ago? And the special thing is that it actually understands ClickHouse SQL dialect. It will not give you like some crap like PostgreSQL. It will give you a real ClickHouse nice queries that you want to get. Okay, and it is named as Gen AI, and it is using reg, but let's not focus about it. Let's not amplify all the hype. The most significant is that it works. It works as you expect. Okay, what do we have in our blog? If you want to know how to load a really large data sets, like trillions of records every day into ClickHouse, read the article named Supercharging Your Large Data Loads. If you want to use ClickHouse for machine learning, there is another article, Forecasting Using ML. Another article, probably you don't need it, but we just explained how we are saving millions of dollars per year by changing the configuration of Kubernetes slightly. And about this Gen AI feature, there is also an article. If you are interested, don't hesitate, open and read it. Subscribe to our YouTube channel. There will be all the recording from all the meetups and webinars. And if you are interested in offline ClickHouse meetups, we have plenty of them in Europe, in the United States, in nearest month. Just open our website or our repository, and there is a list of all the meetups around the world. The latest meetup was in Amsterdam just 2 days ago, and probably you missed it. But you don't want to miss our meetups. Okay, thank you. Now we have about 4 minutes for questions.
Okay, we don't have a huge number of questions this week, but lots of praise for all the performance optimizations, Alexei. I think people really appreciate those. The main one we've got on is any thoughts on providing search engine type features in ClickHouse? And just to clarify that, a few things there, like what about things like spelling check, string distance functions? Do we have any plans around that?
Yeah, it should be interesting to provide the functions for some special type of string comparison and string search. And we have just a few of functions of this type, like n-gram distance that compares like fragments of strings. But it will be more interesting to also implement some classification functions. We have some of them, like language character set classification, but I wanted to do something more generic, like mood classification, sentiment analysis. And sometimes you don't have to use complex transformers models. You can do whatever you have learned 20 years ago, like naive Bayes method. And it should work and it should be fast. So I am looking forward for all these features. Probably we'll have a chance to implement them.
Yeah, I know basic string functions. There's a tick issue open, which is marked as a low-hanging fruit. So if somebody wants to try and make an early contribution, make a contribution to ClickHouse for the first time, some of the string distance functions are probably a good place to start. The question on the external group by improvement. Do we expect that to have any additional memory overhead for aggregation and merges? For aggregations?
Good question, because we used to have a lot of additional memory overhead, but it was yet another optimization that I did not include in the slides. But in the version 23.10, the memory usage for external group by, for the merging stage of external group by, was optimized as well.
Oh, awesome. Well, good question. Final one, we have 2 more, but maybe just squeeze these last 2 in. Any plans to support partial updates where only some columns are getting updated frequently in the context of replacing merge tree? So do we have any plans, or maybe it could be a new table engine? Do we have any plans for performance improvements around replacing merge tree? And in the context, and with it being specifically where only a few columns are being updated?
Yeah, this is interesting, but this feature request requires a lot of detalization. It will be interesting to add something to support this, but we should take care to make it not too hard to use, not too unnatural, not too special. We want something to make it accessible for a large number of use cases, a large number of scenarios. I don't want to just add 100-second table engine into ClickHouse and hope that probably 1 or 2 users on the internet will use it.
Okay, I think this has actually been answered. This final question is, do we have any benchmark for comparing performance differences between ClickHouse versions? I know we obviously have ClickBench, and there's if you go to ClickBench, the results, and you do /versions, it should show you the performance difference between versions. But I know Ilya's actively working on trying to update that. It only goes up to 23.7 right now. Do you have any other suggestions, Alexei, for seeing differences between versions? Performance improvements as a kind of across the improvements that we've made?
If you check ClickBench, you can find a script that will automatically spin up a virtual machine in AWS. You only have to authenticate, and it will automatically run the benchmark, collect the numbers, and even post these numbers to our database. And then it will automatically terminate the service. So it will take like 20 minutes, but you only have to press like a few buttons, and it will run completely unattended. So you can run this benchmark for all ClickHouse version in parallel if you want, and update the results. It will be easy.
Okay, and that's everything. Tyler, do you want to say a few final words?
Yeah, amazing. I have spent, embarrassingly, because this tells you exactly how old I am, I've spent more than 25 years working with databases, and fundamentally having the opportunity to talk about the software that other people build without having to try and build it myself. And there's something delightful about a release, ClickHouse 23.10, where there are more performance optimizations than features. How beautiful is that? My ask of all of you who are watching this either live or who are watching it in the future is try it. Tell us what's amazing. And more importantly, tell us what's not, so that we can make it more amazing for your use case in the future. Join us on Slack, clickhouse.com/Slack. Join us in our Slack community, meetup.com/pro/ClickHouse. Alexei mentioned a few. We just had one in Amsterdam. Upcoming is Beijing, San Francisco, Singapore, Berlin, another in Amsterdam, Boston, New York, Sydney, all between now and the end of the year. We're doing, I think, almost 4 times the number of meetups this year that we did last. Come, if we're in a space where you're at, join us. And if we're not having a meetup in a space where you're at, I'm Tyler at ClickHouse. Reach out to me and we'll make one happen in your local city. Thank you so much for joining us. We really appreciate it. As I've said all the times, but I mean it, an open source project is defined by the users who use it, not the people who build it. We are deeply grateful for our contributors. They are what make ClickHouse amazing. What makes ClickHouse a cool story to tell is the things that you all are building on top of it. So feel free to share your stories with us, and we'll see you in a month for the 23.11 community call. Thank you so much, and we'll talk soon. Bye.